Welcome to another deep dive. This time we're going to be chasing the northern lights.
Oh, yeah.
The auroras that have had people mesmerized for centuries and centuries.
Absolutely.
We're not just going to, like scratch the surface here. We're going to dig deep into the science and how they work. But we're also going to do a little time traveling.
Oh, cool.
See how different cultures have viewed these incredible events up in the sky.
I love that.
And to help guide us, we have a couple of sources. One is a Wikipedia article.
Okay.
Which, as you know, gets into the nitty-gritty.
Oh, yeah, they can get pretty in-depth.
It really does. And then just to balance that out, we have a NASA educational site.
Okay.
So it kind of like balances out, the very technical with something a little more approachable.
Yeah, I like that.
Yeah, so before we get into the science of it all, I think the first question is, what is an aurora?
Right.
I mean, I've seen incredible, curtains of light shifting and changing colors.
Yeah.
But I'm not sure I really know what I'm looking at.
It's fascinating. What's so cool about auroras is they bridge this gap between science and spirituality.
I can see that.
I mean, we can explain the physics behind them, but there's still this undeniable wonder.
Oh, absolutely.
That you feel when you see them firsthand.
Yeah.
It's like, imagine the sun is constantly sending us invisible messages in the form of these tiny electrically charged particles.
Okay.
And the aurora is Earth's way of writing those messages across the sky.
Wow.
These particles are carried by what we call solar wind.
Okay.
And they collide with Earth's atmosphere, and bam, we get a dazzling light show.
So it's like the sun is like whispering to us all the time.
Yeah.
And then sometimes it just shouts.
Exactly. And those shouts, those bursts of energy are often caused by what we call coronal mass ejections.
Okay.
So imagine the sun sneezes, and instead of droplets, it sends out this giant cloud of electrically charged stuff towards us.
Okay, so the sun's sending these particles our way. What actually makes them light up the sky, though?
Well, luckily for us, Earth has this amazing magnetic field.
Oh, right.
That acts like a shield, deflecting most of those particles.
Okay.
But like any good shield, it has weak points at the north and south poles.
Uh-huh.
So imagine like a giant ring or an oval around Earth poles. That's what we call the auroral oval.
Okay.
And that's where the aurora happens most often because that's where those particles can sneak through.
So these sneaky particles, they get past Earth's defenses at the poles, and then what happens?
When those charged particles hit our atmosphere, they collide with oxygen and nitrogen molecules.
Oh.
The gases that make up our air.
Right.
So it's like a cosmic billiard game.
Right.
But instead of balls, we have these tiny particles bumping into gas molecules.
Okay, so I'm picturing this cosmic game of billiards.
Yeah.
What happens when they collide?
That collision causes the gas molecules to get excited, and they release that energy as light.
Okay.
And different gases release different colors of light.
Oh, okay.
Oxygen, for example, gives off green or red light, while nitrogen emits blue or purple.
Oh, wow.
It's like a giant natural neon sign.
So those different colors we see in the aurora, that's just different gases being excited by these particles from the sun?
And not only that, but the altitude plays a role too.
Oh.
If the oxygen is higher up in the atmosphere, we get red auroras lower down. It's green.
Oh, wow.
It's like the atmosphere is a giant canvas, and the particles are painting these incredible swirling patterns of light.
So we've got the what and the how of auroras, but are we the only planet that has this light show?
That's a great question. Actually, no, we're not alone in this cosmic light show. It turns out auroras have been spotted on other planets in our solar system.
Really?
Yeah, like the Jupiter, Saturn, Uranus, Neptune.
Wow.
Even Mars and Venus have their own versions of auroras, though they're a bit different from what we see on Earth.
Hold on, Jupiter has auroras.
Yeah.
That's crazy what causes them on other planets. Is it the same process as on Earth?
The basic principle is the same charged particles interacting with a planet's atmosphere and magnetic field.
Okay.
But what's really cool is that on some planets like Jupiter, the auroras aren't just caused by the sun, they're also caused by their moons.
Their moons. Are you serious? How does that even work?
Jupiter has these incredibly active moons, like Io, that are constantly spewing out volcanic material.
Okay.
This material becomes ionized, meaning it gets electrically charged.
Right.
And interacts with Jupiter's magnetic field, creating these incredible auroral displays.
So it's like Jupiter has its own personalized light show powered by its moons.
Pretty much.
That's wild. It makes you realize just how diverse and awe-inspiring our solar system is.
Absolutely. And it gets even more mind-boggling.
Oh, no.
We've even observed auroras on a brown dwarf star.
Why?
A celestial object is not quite a star and not quite a planet.
Okay.
It's way beyond our solar system, light years away. Yet these same dazzling displays of light are happening there too.
This is incredible. It really makes you wonder what other wonders are out there in the vastness of space. Okay, so we've covered the science behind auroras, and it turns out they're not just an earthly phenomenon. But let's go back in time for a bit. I'm really curious about how different cultures have viewed and interpreted these lights throughout history.
That's where it gets really interesting. You see, long before we had the scientific understanding of auroras, people around the world developed their own myths and legends to explain these celestial displays.
I can imagine these lights dancing across the sky must have seemed so magical and mysterious to ancient civilizations. What kind of stories did they come up with?
Well, in ancient China, for example, auroras were seen as a celestial battle between good and evil dragons, their fiery breath illuminating the night sky. It was believed that the outcome of these battles could influence the fate of the empire.
Wow, a battle between dragons. That's pretty epic.
Yeah.
What other cultural perspectives did you find?
The Inuit people of the Arctic believed that the aurora was the spirits of their ancestors dancing across the sky playing a ball game with a walrus skull. They saw it as a connection to their past, a reminder of those that came before them.
That's beautiful. It's amazing how these lights have woven themselves into the fabric of so many cultures.
And in Scandinavian folklore, the aurora was often associated with the Valkyries, female figures who decided who would live or die in battle and carried the fallen warriors to the afterlife. Valhalla, imagine these warrior women riding across the sky, their shimmering armor, creating the auroral lights.
That's such a powerful image. It really brings those myths to life.
It's fascinating, isn't it, how the same phenomenon can be interpreted in so many different ways, reflecting the beliefs, values, and experiences of each culture.
It makes you realize that science is just one way of understanding the world. These myths and legends offer a different kind of knowledge, a deeper connection to the human experience.
Exactly. And I think it's important to remember that even with all our scientific advancements, there's still a sense of mystery and wonder surrounding auroras.
Absolutely. Knowing the science behind it doesn't take away from the awe-inspiring experience of actually seeing one. In fact, I've heard that witnessing an aurora firsthand can be a truly transformative experience.
It can be incredibly powerful. Many people describe feeling a deep sense of awe and connection to the cosmos when they see the aurora. It's about feeling small, yet part of something much bigger.
It's like realizing that our little planet is just a tiny speck in a vast and wondrous universe. I can see how that would shift your perspective.
And it's not just about the visual spectacle. It's about the feeling you get when you're standing under those dancing lights. It can be deeply moving, almost spiritual for some people.
I'm starting to understand why people become obsessed with chasing auroras. It's not just about ticking off an item on a bucket list. It's about experiencing something truly unique and profound.
Exactly. It's about embracing the adventure, the challenge, and the sheer wonder of being in those incredible environments.
So for someone who's never seen an aurora, what's the best way to go about witnessing this incredible phenomenon? Is it as simple as booking a trip to Alaska or Iceland and looking up?
Well, it's not quite that simple. Aurora hunting takes a bit of planning, and let's be honest, a bit of luck.
Yeah.
You need to be in the right place at the right time, and that often means venturing to remote, high-latitude regions during the winter months.
So it's not exactly a casual weekend getaway. What are some of the challenges people face when chasing auroras?
Well, first off, you're dealing with unpredictable weather. Clear, dark skies are essential for aurora viewing, and those can be hard to come by in places known for their long, dark winters. And even if the weather cooperates, there's no guarantee that the aurora will show up.
So you could travel all the way to Iceland, bundle up in your warmest gear, and still miss out.
That's the gamble you take with aurora hunting. You're at the mercy of solar activity, which can be unpredictable. There are forecasts that can help you gauge the likelihood of auroral activity, but it's not an exact science.
It sounds like patience and persistence are key for any aspiring aurora chaser. Have you ever had any frustrating experiences while hunting auroras?
Oh, absolutely. I remember one trip to Norway where I spent a week camped out in a remote cabin, braving sub-zero temperatures and blizzard conditions, all for a chance to see the aurora night after night. I stayed up late scanning the sky, but all I saw were clouds and snow.
That sounds brutal. Did you ever get to see the aurora on that trip?
On my very last night, just as I was about to give up hope, the clouds parted, and there was a vibrant green arc stretching across the sky. It was breathtaking.
Talk about a rewarding experience. It sounds like the challenges and frustrations just make those moments when you finally see the aurora even more special.
It's true. There's a sense of accomplishment, a feeling that you've earned that glimpse of something truly extraordinary and makes you appreciate the power and beauty of nature even more.
Now, we've talked about the science of auroras, the myths they've inspired, and even the challenges of chasing them. But I'm curious, what does the future hold for aurora research? Are there still mysteries to be uncovered?
Oh, absolutely. Aurora research is constantly evolving, as our technology and understanding can prove. One area that's particularly exciting is the development of better predictive models.
So being able to forecast auroras more accurately, that would be a game changer for aurora chasers.
For sure, right now we rely on solar monitoring and various indicators, but there's still a lot of uncertainty. Imagine being able to predict the timing, location, and intensity of an aurora with greater precision. It would revolutionize our understanding of space weather and help us prepare for potential impacts on our technology and infrastructure.
That's incredible. It's like we're finally starting to unlock the secrets of these celestial displays.
And it's not just about predicting auroras. Scientists are also exploring the potential impact of auroras on Earth's systems. There's growing evidence that auroras could influence atmospheric circulation patterns, potentially affecting weather systems at lower latitudes.
Wait, so you're telling me that those lights dancing in the sky could actually have ripple effects down here on Earth?
It's a possibility. It's still a relatively new field of study. But the connections between auroras and our planet's environment are becoming increasingly apparent.
That's mind-blowing. It really highlights the interconnectedness of everything in the universe.
And another fascinating area of research is the exploration of auroras on other planets and moons by studying auroras on different worlds. We can gain a deeper understanding of the diverse magnetic environments and atmospheric conditions that exist throughout our solar system and beyond.
It's like each planet's aurora is a unique fingerprint, revealing clues about its history and evolution.
Exactly. And with advancements in space exploration and technology, we're constantly making new discoveries about auroras and their significance in the grand scheme of things.
It's amazing to think how far we've come in our understanding of auroras, from ancient myths and legends to cutting-edge scientific research. And who knows what incredible discoveries await us in the future.
The possibilities are endless. And that's what makes science so exciting, isn't it? The pursuit of knowledge, the constant exploration, the never-ending quest for understanding.
You know, one thing that really excites me is the role of citizen science in aurora research. It seems like anyone with a camera and a passion for the night sky can contribute to our understanding of this phenomenon.
Absolutely. Citizen scientists play a vital role in aurora research, providing valuable observations and data from all over the world. With so many people capturing images and videos of auroras, we're getting a more comprehensive view of these displays than ever before.
It's like crowdsourcing the aurora, and it's not just about collecting data. It's about engaging the public in scientific discovery, inspiring a sense of wonder and curiosity about the world around us. It's a powerful reminder that science isn't just confined to laboratories and research institutions. It's something we can all participate in.
And it's a beautiful example of how collaboration and shared passion can lead to remarkable insights. Citizen scientists are helping us unlock the secrets of the aurora and deepening our appreciation for this incredible phenomenon.
And maybe even, plan an aurora adventure of your own someday.
Yeah, that'd be amazing.
Right.
And remember, even if you never see an aurora in person, you can still appreciate the science behind it, the stories it's inspired, and just, that connection that it reveals between our planet and the cosmos.
Yeah, that's the perfect takeaway from this deep dive into the auroras. We've journeyed from the science of the sun's breath to the myths whispered under those dancing lights.
Yeah.
We even peeked at aurora on Alien Worlds.
We did.
It's humbling to think that the universe is so chock full of wonders.
It really is.
Seen and unseen.
Absolutely.
So to our listener, wherever you are, if this has sparked your curiosity, I encourage you to go and do some exploring of your own.
Yeah.
And maybe read up on those ancient myths we talked about, or look at some of the incredible pictures that aurora photographers have captured.
That's a good idea.
And who knows, maybe you'll be inspired to plan an aurora adventure of your own.
Yeah.
Well, it has been an incredible journey exploring the auroras. From the science behind how those charged particles paint the sky to the way different cultures have interpreted these celestial ballets.
It's amazing.
It's a reminder that there's still so much out there to discover and understand.
Absolutely. And even with all of our scientific knowledge, there's still a sense of mystery and awe that surrounds the auroras.
That's very true.
It's a phenomenon that connects us to something bigger than ourselves, to the vastness of space and the intricate workings of our universe.
Well said. So to our listener out there,
Yeah.
keep looking up, keep asking questions, and never lose your sense of wonder.
The universe is full of secrets waiting to be uncovered, and who knows what amazing discoveries await us just beyond the horizon.